Alright YouTube, what's going on? It's Rewire Strike. So today I'm going to be classifying nonlinear PDEs. Um, Classifying PDEs helps you understand certain characteristics about the partial differential equation. And there's two formulas that you need to stick to in order to evaluate a PDE's linearity. The first one being the higher order, A UTT plus B UXT plus C UXX equals f of x of t and t. We're going to call this equation 1. And similarly, the lower order ones is A of u of t plus B u of x plus C of u equals f of x of t. This is equal to equation number 2. In both of these equations, you're going to want to be looking at the left-hand side. In particular, you're going to be looking at the coefficients, A, B, and C, in both equations. And on the right-hand side, you're going to be looking at the function. It could be 0, it could be a function, it depends. But looking at the coefficients on the left and the function on the right help you classify each PDE. There's 4 major classifications. The first one is going to be linear. A linear PDE means that the highest order derivatives of u have coefficients that only depend on independent variables. And independent variables can be a constant, like 1 or -1, or it could be x or y or t. Note that in a linear equation, the right-hand side does not equal a function of u. It can be a function of x and t, but it cannot be a function of u. This is important. The second classification is semilinear. In a semilinear case, the coefficients of highest order derivatives do not depend on u or any of its derivatives. The lower order derivatives can, and the right-hand side, the function part, may be a function of u. The third type is quasi-linear. This is when the coefficients of the highest order derivatives depend on lower order derivatives. And also the right-hand side can equal u. This one is a pretty easy giveaway. It basically means that you have something like u of x times u of x, something like that. If it doesn't qualify to be any of the following 3, either linear, semilinear, or quasi, then the function is nonlinear. That's for everything else. Exclamation point, exclamation point. So let's take a look at our first example. So our first example is u of t plus u of tx minus uxx plus ux squared equals sine of u. So now we know that the right-hand side is a function of u. Thus, this implies that the function is not linear. It is not linear. Now, let's take a look at the left-hand side to see if we can determine what category it's actually in. So, using equation 1, which is a of u of tt plus b of u of x of t plus c of u of x equals f of x of t, right? We could see here and compare that here b is equal to -1, c is equal to -1, and there doesn't seem to be a second derivative of t, so a is equal to 0. Alright, so I'm going to write this as 0 times u of t plus 1 times u of t of x minus 1 times u of x. Now we have these extra terms here, u of t and u of x squared, and I can't exclude them, so I'm going to rewrite the equation of u of x times u of x. Now, let me complete writing the equation. Sine of u. We know we've already determined that since the right-hand side is a function of u, it cannot be considered a linear case. So let's take a step up to semilinear. If we look at the definition of semilinear, I'll state it again, is that the coefficients of highest order derivatives do not depend on u or any of its u's derivatives, and the lower order derivatives can. So the highest order derivatives are going to be ones that I tried to identify, and they're going to be right here. Oops, excuse me. They're going to be right here. Now this one goes to 0, so it doesn't exist, but these two do exist, and these are second derivatives, one with respect to x and t, one with respect to only x. So these highest derivatives coefficients are constants. That means they do not depend on u. So b and c don't depend on u or any u primes. So we take a look at our lower order derivatives, which is u of t and u of x times u of x. Now u of x times u of x, well, that's a lower order derivative u of x times a derivative of u with respect to x, u of x. Thus, we can imply that it is semi-linear. Excuse my handwriting. And that's the correct answer. So let's go to question number 2. Here we have u of x plus uxx plus uy plus uyy equals sine of xy. Now note, this is equal function of x, sine of x and y is equal to a function of only x and y variables. So by linearity, this checks out on the right hand side. So now let's check the left hand side. So by using equation 1, which is a u of t plus b u of t of x plus c u of x, we can identify the following, that a is equal to 1, b is equal to 0, and c is equal to 1 again. And our lower order derivative, which is u of x, has a 1 in it as well, and u of y is the same case. So let's rewrite the equation as 1 times ux of x, y of y, plus 0 times ut of x plus 1 times ux of x plus u of x plus u of y equals a function of x and y, which that's what it is. So this goes to 0, and we know that these don't have functions of u as coefficients or any of its derivatives, so it is not quasi. So it's somewhere below quasi, but above linear. And we know that none of the lower order derivatives depend on u, so it is not semi. So the only conclusion that we have left is that it is linear. And for precision's sake, since the right hand side does not equal 0 for all of x and y, it's a function of x and y, we'll say it is inhomogeneous. Now, let's take a look at the second equation. The second equation, on the right hand side, we have a function of u. Right, we have a function of x and y, and including u. Thus, since there's a u here, it is not linear. Cross that out. Now, so a step up from linear would be semilinear. So let's take a look at the left hand side. Once again, we have 1s as our coefficients, right? And for the lower ones, we have a negative 1 here and a positive 1 here. This is a negative 1. So all the coefficients do not depend on u or any of u's derivatives. Thus, quasi is not the correct answer. So we can't say it's linear and we can't say it's quasi. So it falls somewhere in between. So this is semi-linear. All right. Now you're probably wondering, why did you qualify as nonlinear? Because I'll go explain. When we see an actual nonlinear case, this is semi-linear. So let's take a look at the next example. The next example is u of t plus ux of x plus ut equals f of xt. Now the right hand side is equal to f of xt, so linear checks out on the right hand side. Now when we take a look at the left hand side, the coefficients are 1 here and here, and we also have an x coefficient here, x. And x is considered an independent variable on the right hand side, f of x of t. So this is a linear equation that is also more precise, inhomogeneous as well. So that's the correct answer. Now we go to the next one. The right hand side equals to 0, which checks out that it's a function of x of t, but it's equal to 0 for all x and t. So the right hand side is homogeneous, and once when it's homogeneous, we know it's not a function of u anymore. That's it. It's 0. Let's take a look at the left hand side, because the right hand side being homogeneous doesn't tell us anything. It doesn't tell us it's linear. Well, it can be linear, but it doesn't tell us enough. So let's take a look at the left hand side. Now we start with the highest order derivatives like we've been doing, and here we find out that by equation 1, a of u of t plus b of u of x plus c, t of x plus c u x of x equals 0. We see here that a is equal to 0 because there is no second derivative with respect to t. B is equal to -1 right here. And c has two components, so we'll say c is going to be equal to u plus u squared, right? Because we can factor out a u x of x right here. That's the same thing, minus and plus on the left hand side. Ut minus utx equals 0. So we cross these out as it not existent. But C, well, let's take a look at C. What does one of our definitions say? Well, our quasi definition states clearly that if the coefficients of the highest order derivatives depend on lower order derivatives, that implies that because we have u of t plus c of u x of x minus 1 times ut of x equals 0, this highest order derivative, which is ut of x, t of x, it has a constant which is independent, but we know that c is a function of u. Thus, our coefficients are lower order derivatives. They're the lowest order you can. They are not a derivative. They're the lowest order. That's not u prime or u double prime. It's just, there's no derivative. So it's just quasi. linear. Alright, let's check our next example. So, our next example is UTT times UXX plus UXX times UTTT equals f of u, x, and t. So our right hand side implies that we have a function of u, x, and t, which implies it is not linear. And all of our coefficients here are derivatives of u. So we know that it is not the highest order derivative depends on u. So we know that it is not semi. So our only choice we have left is quasi-linear. And that's the correct answer. Alright. Now we keep going. Here comes the doozy. Alright, I'm going to rewrite this equation. We have e to the power of uxtt minus uxt uxxx plus u squared equals 0. I'm going to rewrite this equation to get all the derivatives on one side. E ux of t minus u x of t times u x of x of x of x equals negative u squared. This implies that the right hand side is a function of u. Thus, it is not linear. Now, the highest derivative here is going to be ux of x, and its coefficient is a function of u. So we know it is not semi. However, we have a second highest derivative. This is not the only highest derivative. This is of order 3. This one right here is a function of an order 3 derivative. That implies that it is not quasi. Since it's not quasi, it's not semi, and it's not linear, this is fully, I'm going to write fully, non-linear. And I think that's my last example. So I hope I helped you all understand the differences between the different cases of linearity. Using these steps and understanding these simple rules can help you understand a partial differential's characteristics, which helps you solve the equation. Thank you so much for watching. Don't forget to like and subscribe.